All right, good morning, everyone. All right, starting with number one on the morning review. All right, customer at a gas station is pumping gas into his gas tank. The rate of flow of gasoline is modeled by a differentiable function where F of T is measured in gallons per second and T is measured in seconds since pumping begins. Selected values of F of T are given in the table. Okay. Using correct units, interpret the meaning of the depth integral from 60 to 135 of F of T dt in the context of this problem. We're going to use a Wright-Riemann sum. And they're telling us how the intervals will look from 60 to 90, 90 to 120, 120 to 135. So for A, so then the width between each of these subintervals from 60 to 90 is 30, 90 to 120 is another 30 units, from 120 to 135 is 15 units. So Wright-Riemann sums, this is our width for each of our, for the first rectangle, width of the second rectangle, width of the third rectangle, and then we want to pick the right endpoint of each subinterval. So first rectangle will be 30 times 0.15, second rectangle will be 30 times 0.1, last rectangle will be 15 times 0.05. And if we're accumulating all these gallons per second over a period of time, then that's going to translate to the total gas or total amount of gasoline that the customer has pumped into his gas tank in that time period. So depth integral is the amount of gas pumped into the gas tank between 60 and 135 seconds. And if we add up the area, we're essentially doing the approximation of the region under the curve, and that's going to give us 8.25 gallons. Part B, must there exist a value for C between 60 and 120 such that F prime of C is equal to 0? Now, sometimes it's an IVT problem, sometimes it's a mean value theorem problem. And I say mean value theorem, in this case, we can also call this Rolle's theorem if it falls under that category. Sometimes students have some trouble deciding, wait, how do I know whether it's IVT or mean value theorem? I think typically we always want to see if IVT can solve the problem for us because it's easier, doesn't require doesn't require calculus. We just have to look to see, if my target point is 0, then is there a point below 0 and a point above 0? And if there is, the graph's going to have to cross through 0 somewhere between. That would be nice if we had the F prime table. We don't have the F prime table, though, so we can't really rely on IVT because we don't have any data at the F prime level for us to compare to look for a value below 0 and a value above 0. What we do have, though, is we have f of t. F of t, we know f prime is at the slope level of f of t. So if I can somehow show that these order pairs at the f of t level is producing a slope 0, then I can guarantee there must be an f prime of 0, f prime value of 0. And we can call it a mean value theorem, but because we're looking for f prime 0, we can also think of it as Rolle's theorem. They're interchangeable as long as you're looking for slope 0. So mean value theorem we can also just specify as mean value theorem. Now, in order for slope 0 to happen, we need 2 points that produce the same y value. And looks like at 60 and 120, we do have 2 f of t values that are the same. So if I were to find the slope between these 2 points, 0.1 minus 0.1 over 120 minus 60, that's going to give me a 0. So we're looking for 2 of the same y values. So that means if the graph hits 2 of the same points, it's got to either go up and come down to this, or it's got to go down and come back up to this. Either way, it's going to have to create a slope 0 along the way. Now, we know that this is a differentiable function, so it passes all the conditions that we need for mean value theorem. It's differentiable. If it's differentiable, it's got to be continuous, and it fulfills the condition for mean value theorem. Yeah. You don't have to do units. Yeah, good question. So f of t is differentiable and therefore continuous. Parentheses with differentiability, brackets with continuity. And since we found 2 points that produces a slope of 0 by Rolle's theorem, you can also say mean value theorem. That's fine as well. Or MVT, there must be a time such that f prime of c is equal to 0 in the time interval from 60 to 120. Part C, the rate of flow of gasoline can be modeled by G of t. So before we had an approximation at different time values. Now we have something that potentially is more accurate. We now have G of t that represents the rate of flow of gasoline between 0 and 150. So we have something that's more accurate than the table. Using this model, find the average rate of flow of gasoline. So average rate of flow, that should give us a hint that we're involving average value theorem. So we should have to show the setup in our calculator or for our calculations. And then we can use our calculator for the rest. So average value theorem, 1 over b minus a, integral from a to b of our function. And we just set it up here. My a value is 0, my b value is 150. I go through average value theorem, and my units will stay the same if I go through average value theorem, because the integral of g of t is going to make it rise above up to gallons level, but then divided by 150 is going to take it back down to gallons per second. Next part D. Using the model at G that we've been using, find the value of G prime of 140. So we can just use math 8 to get to G prime. So we do math 8, plug in 140, and G of t is already at gallons per second. So we know that G prime will take it down to gallons per second squared. And anytime we're at the second derivative level and they're asking you to interpret the meaning, you just know that you want to use words like rate is increasing or the rate is decreasing. We don't want to say rate of a rate. If we say rate is changing, it's probably not as clear as we could be. It's not wrong. I mean, it's not incorrect, but it's not as clear. We want to be able to specify, okay, The negative means the rate is decreasing. Positive would mean that the rate is increasing. And also, we don't want to use words like velocity and acceleration. It doesn't quite fit the context of this problem.
Is it fine if we or should we get rid of the negative sign if we already said decreasing?
Yeah, we probably should get rid of the negative sign. I probably won't take off any points for that, but the College Board may. Okay, any questions with number 1? Okay, next. Okay, this is a rate in, rate out problem here. Coal is burning in the furnace, thus exhausting the resource. The rate at which coal is burning is measured in pounds per hour, given by B of T. At 2 hours, so this is a rate here, B of T is a rate. At 2 hours, a worker starts supplying additional coal into the furnace. The rate at which coal is being added is measured in pounds per hour, also pounds per hour, given by S of T. So we have rate at which coal is burning, and we have a rate at which coal is being added into the furnace. The worker stops adding coal at 5 hours. At T equals 0 hour, there are 500 pounds of coal in the furnace. Okay. Find the total amount of coal added by the worker. So here, we only care about S of T here. We don't care about the fact that there's 500 pounds to begin with, and we don't involve B of T either. So for A, we're just doing the integral of S of T. Okay. And the coal is being added between 2 and 5 hours, right? At 2 hours, worker starts to add additional coal, and then at 5 hours, he stops. So part A is just the integral from 2 to 5 of S of T dt. S of T is pounds per hour. So if we take the antiderivative, that's going to strip away that per hour and just give us pounds. And this is the calculator setup problem here. Is the amount of coal in the furnace increasing or decreasing at T equals 4 hours? So we basically have to compare the rate at which S of T and B of T compare to each other, right? If B of T is greater than S of T, that means the amount of coal is decreasing because the rate at which it's being burned is more than what is being added. But if S of T is greater than B of T at that moment in time, that means the amount of coal in the furnace is increasing. So we just have to plug in for S of T and B of T and just compare their values here. So S of 4 is a certain value, B of 4 is a certain value. But if I do S of 4 minus B of 4, I get a positive 1.986. If I do S of T minus B of T, I know that a positive number would mean the amount is increasing. If I get a negative number, then I know it's decreasing. So that's why this is set up as S of 4 minus B of 4. But you could also find them separately and then subtract it and then, or compare them and then see, okay, S of 4 is greater than B of 4. Therefore, the amount of coal in the furnace is increasing at T equals 4 hours. So there's more than one way to do part B, but it does involve having to look at S of 4 and B of 4 and actually comparing their values and making your conclusion from there. Next up, find S prime of 3. So S of T is given, so S prime would require us to do math 8. So if we do math 8 on S of T, we can find S prime of 8 and S prime of 3. And because S of T is in terms of pounds per hour, S prime will be pounds per hour squared, pounds per hour per hour. And S prime of 3 gave us a negative value. So we know that the rate is decreasing. Any questions? Part D, write a piecewise function AFT that gives the total amount of coal in the furnace at any time. So this is the formula that we've been practicing with when it comes to rate in, rate out problems, that there are three sets of information we have to keep track of. How much do we have to begin with? How much has been added? And how much has been removed? So we know 500 is the initial amount of coal in the furnace. We know that the amount added is between hour 2 and hour T. I mean, we go all the way to T equals 5, but we have that flexibility that allows us to find the amount at any point in time between 0 and 5 hours. And then B of T is from 0 to T, right? It's from 2 to T for amount added, since the coal is not getting added for the first 2 hours. So it's nothing happens with S of T from 0 to 2. So from 2 to 5, we are using this formula. From 0 to 2, we're using this formula here. But technically, I guess this can stand. Yeah, that's right. Because we don't want to involve this formula if we're doing 1 or 2. That would mess things up. Yeah, so we do need 2 separate. That's why they said piecewise functions, since we have different scenarios for 0 to 2 versus 2 to 5. Part E, find the minimum and maximum amount of coal. So this is an application of extreme value theorem, and we need to find critical points and endpoints, right? And then test them against the AFT equations. So we know the endpoints are 0 and 5. The critical points are where B of T is equal to S of T. And the way to do that is just look to see where is B of T minus S of T equal to 0. So we can graph B of T, or so basically we can create A prime. We basically set A prime equal to 0. And since A prime is the derivative of each of these terms, 500 goes 0. Integral of S of T just becomes S of T. Integral of B of T just becomes B of T. We're just using second theorem, right? Derivative of these will just strip away the integral here. So S of T minus B of T. So the strategy is we graph this. Graph S of T minus B of T, and then simply look for the x-intercept. I can show that in my calculator here. So S of T, I'll put under Y1. T. So I put S of T under Y1. Under Y2, I'll put B of T 8 sine of 1 over 2 pi. And then I'll create a Y3. And that Y3 will be just Y1 minus Y2. That will represent my S of T minus B of T. And I'm going to unhighlight y1, y2 so I don't have to see all three graphs. My x-min, x-max, I'm going from 0 to 5. So, and then my y-min, y-max, if I look at my coefficients, they're, they're not huge numbers there. So maybe I'll just go from -10 to 10 just to see what happens. Right, hit graph. I'm simply looking for an x-intercept here. Tan cosine 4 pi x over 4. Let me see. Oh, sorry, this is 8 sine of t over 2 pi. Let me try again. Nope. Okay, there we go. I'm looking for an x-intercept between 0 and 5. I can do second trace 0. Pick a point to the left of the x-intercept, hit enter. Pick a point to the right, hit enter. .37. And then piece by piece, we're just entering the 0, the 2, the 4.3, and 5 into AFT to compare the signs. Thank you. Plug into AFT and see which one is the highest and lowest values. So, and also we want to test AF2 since there's a split at 2 here. So we want to consider AF2 as well. So we test 0, 2, 4.3, and 5, all into the respective piecewise functions. And absolute max is the 513, and the absolute minimum is the 497. Sorry, I'm doing BC. Part F, find the average rate of coal burn. This is average value theorem. So we go through average value theorem here for BFT. So part G here says, after 5 hours, the coal continues to burn until there are 0 pounds of coal remaining. Write an equation involving one or more integral expressions that gives the time t equals k that the coal is exhausted. So we know A of 5 is going to be the amount of coal that is in the furnace. And then we know that S of T is going to stop working. We just need to figure out however long it's going to take from 5 until time k, where this integral of B of T is going to burn out all the coal from that we've gathered up until A of 5. So here's our equation here. We want to be able to burn the rest of the coal so that A of 5 minus however long it takes from 5 to k of B of T will equal to 0. Okay, number 3. Solving differential equations here. So we know part A, write an equation with tangent lines. So we have the order pair as 0, 3, t, w. And then our slope is plugging 0, 3 into dw dt, getting 1/2. Normally, point slope form is y minus y sub 1 equals m times x minus x sub 1. We want to adapt our equation of tangent line to be the variables that that's involved. So t is kind of like your x, and w is kind of like your y. So we can replace 0, 3 in for t and w, replace our slope with 1/2, and then we solve for w. W is 1/2 t plus 3. And then we also are doing tangent line approximation. So we are taking this tangent line and plugging in the decimal in for t and getting the approximated temperature. Part B, we're finding y equals w of t. So we have to solve the differential equation. Cross multiply first. We want everything related to w on the left side, everything related to t on the right side. Here, after I cross multiply, I basically have full separation, but the 2 is a little bit out of place. So divide everything by 2. I only want what is the bare minimum on the left side here. So once I have that full separation of variables, take the antiderivative. W becomes w squared over 2. Cosine becomes sine. And once we have our antiderivative, then our steps may be different from here. Okay. After we find our antiderivative, it's up to you in terms of, do you want to solve for w first? Do you want to clean it up a little bit, then solve for c, and then come back to solve for w? Either way, we have 2 goals remaining. We got to solve for c at some point in time, and then we have to be able to isolate w at some point in time. So what I did here was I just got rid of the 2 here. I just multiplied everything through by 2 to make it easier for me to solve for c. And once I got into an equation that feels relatively clean, I'm just going to go ahead and solve for c at this point in time here. So I'm going to plug 0 in for t, 3 in for w, and I'm going to solve for c. So 9 equals 0 plus c, c equals 9. Once I have my c value updated, then I'm going back to solve for w. Solve for w, w is plus or minus square root. Now, these are 2 different solutions here, plus or minus, but we choose the one that allows the y value to be whatever the sign of the y value is. Right? So because the sign of the y value or the w value is 3, we're going to choose the positive square root. If the order pair here was negative, then I would choose the negative square root. Part C, the temperature in the kitchen remains at a constant 20 degrees Celsius. between 0 and 24 hours. The cost of operating the refrigerator actually accumulates at a rate of 0.01 per hour for each degree the temperature exceeds the temperature inside the refrigerator. Right, but do not evaluate an expression that involves an integral that can be used to find the cost of operating the fridge for the 24-hour interval. So we know the temperature remains at 20 degrees, but then over the course of 0 and 24, that WT is going to fluctuate. And as it fluctuates, it's going to create a cost if it's any different than 20. So we're basically accumulating the times when these two are different, and that's causing a change, causing there to be a cost. And then that value is going to have to be multiplied by 0.001 per hour. And then that's going to give us the total amount of dollars. Okay, let me go over number 4 here. We got solving differential equations. There's also a little bit of slow field here. We're just identifying order pairs, plugging in, interpreting that slope value as positive or negative, and then just sketching that segment. Part A, we're just finding the slope of the tangent line. So we're plugging in 1, 2 into the derivative to get our slope. And that's all we need to do, just plugging into our dy dx to find our slope. Part C, find the particular solution. So we're going to go through our processes of separating our variables. So I'm cross multiplying first. Get my dy dx's lined up. Next, I'm going to separate the variables. Looks like the y minus 1 is out of place. I'll divide both sides by y minus 1. The left side is just relying on use substitution, but it's going to end up being natural log. And the right side, I can do a little bit of cleanup and just rely on power rule. So 1 over y minus 1. If you understand this is just going to be natural log, you can skip all the u substitution and just say, okay, this is basically 1 over u du, natural log absolute value of u, which turns into natural log absolute value of y minus 1. Right. Or you can go through the full u substitution steps. Okay, power rule, 1 becomes x on the right side, 2x to the negative 2 becomes 2x to the negative 1 over negative 1. And then here, I'm going to, once the c shows up, you're welcome to solve for c at this point or wait till later. I'm going to try to get y by itself first before I solve for c. Just feels a little bit cleaner. So I'm going to raise both sides with e as the base. I know that e and natural log cancels out. I'm just left with absolute value of y minus 1. The right side, all these are exponents. I want to separate the c away from the rest of the expressions. So e to the x plus 2x times e to the c. I know e to the c is just one big constant. And I can drop the absolute value as well and let c absorb that, add 1 to both sides. So now this is my general equation. And then I'm just going to wait.
Concerts, we always be nice to.
Okay, so I'm just going to wait until this time here to plug in my order pair. So 1 in for x, 2 in for y. And I'm just working my way down to solving for c. So 2 gets replaces y, 1 replaces x, e to the 3rd power. Okay, subtract 1 from both sides, divide both sides by e cubed. So c is equal to 1 over e cubed. Once I have my c value, put it back into my general equation. So any of these variations are fine at the end, as long as we involve 1 over e cubed somehow or some way.
Thanks for that. We're thinking about doing.
Okay, any questions with any of the previous problems? Yeah. Mm-hmm.
Could you go to number 2? Can you explain? Get G.
So number 2, for E, we basically have to find critical points and endpoints because this is EVT, right? Extreme value theorem. And we have a piecewise function here for A of T. There's different scenarios here. One
So-
scenario.
Is something set up by your ensemble,
Case,
like
have
a
to make sure you
performance
submit a picture
opportunity,
of
but
your
it's
case
not.
with-
For 0 to 2 is a different scenario than from 2 to 5 because from 0 to 2, S of T hasn't started working yet. No coal has been added.
It's a little different this meeting, so we're gonna go around.
Second, I mean, this.
Music.
My name is C. I'm in band and I play the bari sax and contrabass clarinet. My name is Jack. I'm a senior. I'm in the
Okay, so we find A prime at this level here. So A prime is going to be 500 goes to 0. Integral of S of T just becomes S of T. Integral of B of T becomes B of T. So A prime is just S of T minus B of T. We know we have to, we can find a critical point at this stage here. So we want to figure out where is A prime equal to 0. So we graph S of T minus B of T in our calculator. So I did Y1 being S of T. I had Y2 being S of T. I didn't want to graph them, so I unhighlight the equal sign. And I just, under Y3, I did Y1 minus Y2. And I graphed it. And I looked for the x-intercept. That's my critical point. So I need to test 0, 4.3. That's what I found, and 5. But also, there is a change at 2 here. So 2 is also a critical point since that's a cutoff between one piecewise and the second piecewise, because we know that there's a shift in something changing at 2 hours, because at 2 hours the coal is getting added into the furnace. So we know there's something, there's a critical point at 2 as well. So then we take 0, 2, 4.3, and 5, dump it all into the AFT formula, and then compare the values. And the values are just going to tell us whichever is the highest is the highest amount, maximum amount of coal in the furnace, and whatever is the lowest is the minimum amount of coal in the furnace. We do need to do something unique for AF2. For AF2, we don't plug into for the first one here, we plug into, I'm sorry, for AF2, we can plug into either one since they'll give us the same answer. So that's fine. So AF0, we know is initial. AF2, either one will give us 497. AF 4.3, we use this one, and AF 5, we also use this one here. For G, after 5 hours, coal continues to burn until there are 0 pounds of coal remaining. Write an equation involving one or more integral expression that gives the time t as k that the coal is exhausted. So we know A of 5 is the total amount of coal that is left to burn off. Right? We know after 5 hours, there's no more coal being added. So we only have to worry about how long will it take for this B of t to completely use up the coal. So we just want to let it go from 5 to however long it's going to take. However long it's going to take for this to equal that, so that when I subtract it, I get 0. Or you can write it out this way too. You can say, okay, whatever it takes for a of 5 to equal the integral from 5 to k of b of t dp. You can write it this way as well. That's fine. Maybe that's more straightforward.
That's a new page 3C.
Yeah, this is kind of a tougher one here. The idea is that, yeah, it says the temperature remains at a constant 20 degrees. The cost of operating the temperature accumulates for each degree that the temperature exceeds inside the fridge. W of t. Operating each degree that temperature in the kitchen exceeds the temperature inside the fridge. So we have to look at the difference between the temperature in the kitchen versus the temperature so the kitchen is 20 degrees Celsius temperature. So W of T is the temperature inside the fridge. So anytime that the temperature of the kitchen exceeds the temperature inside the fridge, there's going to be a cost we have to worry about. So we're basically looking at all the times when 20 minus W of T is going to produce a value that is positive. And once it produces that value, then we multiply by 0.001, which will accumulate our cost over the course of this period. Yeah, that's kind of tough. Okay, any other questions?
Did you go piecewise one on second FRQ?
So the reason why this is a piecewise here is because S of T and B of T are kind of staggered. They're not both working at the same time. So we know that between 0 and 2 hours, S of T is not part of the formula. It's only after 2 hours is coal being added. So between 0 and 2 hours, the coal being added is going to be 0. So we have a slightly different formula between 0 and 2 hours versus from 2 hours to 5 hours. So yeah, we just create a scenario where we strip away that amount added for between 0 and 2 hours. And then we create we add that integral from 2 to 5 of S of T from 2 to 5 hours. But that also means that there's a change at 2, which means we need to include 2 as a critical point when we get to part E. Since all of a sudden you're adding coal, and that's going to shift the change in our critical point. So kind of 2 is kind of like an endpoint as well. So that's why we kind of include that 2. So we include 0, 2, 5, and then whatever critical point we found from A of t minus, from A prime equal to 0, which ends up being 4.3.
I asked something. You're gonna do B, but C.
Okay, I can go over that one, page 17.
Yeah. I didn't see the key first. Like where,
Oh, really?
I
Yeah.
just saw there's a bit. Thank you.
So this is page 17 from the packet here. So we just have to focus on solving the differential equation first. So I cross multiply here. K is just a constant. Again, K is like a value that we want to hold, that we want to keep on the right side, since it's not, yeah, the left side is only for H's and the right side is T and everything else. So once we cross multiply, the root H is a little bit out of place, so divide both sides by root H. Get it ready for power rule. I have integral of H to the negative 1/2, and the right side is negative K. Remember, K is not a variable here, it's a constant, so it stays outside the integral. It's really time that's getting impacted, but it's 1 dt. So 1 becomes T, K stays. We do power rule for H to the negative 1/2, which is H to the 1/2 over 1/2. I just do a little bit of cleanup here, so I don't stare at a complex fraction. Divided by 1/2, the same thing as multiplying by 2. And at this stage, I have a couple of order pairs. They gave us multiple order pairs here because not only do we need to solve for C, we also need to solve for K. And the way you choose which order pair to use is you want to take advantage of the one that has 0. So 0 will allow things to be a little bit easier to isolate. So I'm going to plug 0 in for T, 16 in for H, and see what that gives me. That gives me my C value. I have my C value. I'm going to update my equation with 8. And once I have that 8, I'm going to use my other order pair, which is 30, 4, 30 in for T, 4 in for H, and that will help me solve for K. And once I've solved for K, then I can go back to my equation and begin to work towards solving for H. So I multiply everything, divide everything through by 2. I square both sides, and I eventually made my way down the page.
Can you go over part C on FRQ 3?
Yeah, a lot of students had questions about this. So 20 is the temperature in the kitchen. Sorry. And W of T is the temperature inside the fridge. So each time that the temperature in the kitchen exceeds the temperature inside the fridge, that's when the cost is going to start accumulating. And then so we find all the times when 20 minus WT gives us a value, and then we accumulate that between 0 and 24 hours. And then we take that number of times that occurs and we multiply that by the cost per hour, and that's going to give us the total amount. Multiply, yeah.
Thank you.
Yeah, it's a little bit tougher. Or, yeah. So part C says the rate of flow of gasoline can be modeled by G of T. We know this is the rate. We want to find the average rate of flow of gasoline. So that's indicating that, see, that's average value theorem. So we just have to set up average value theorem. 1 over b minus a integral of the function. Our function is our G of T. And then we should replace a and b with 0 and 50. And the rest is gets plugged into the calculator.
Would you listen to question 2 from Jorge? Do you want to repeat?
Question 2a. Okay, so part A says find the total amount of coal being added by the worker. So if we're just talking about the amount added, we know that has to deal with S of T. S of T is the rate at which coal is being added. So, but S of T is a rate. We want a total amount of coal, so we just take the antiderivative of S of T. That will get us from pounds per hour to total number of pounds. Is that what you're asking about? Part
Yes.
A. Okay.
Do I just input that?
In the calculator, yeah.
Okay.
Yeah, just fill the setup and the rest in your calculator.
Okay. For page 4, part C, what is the first time for ask about FRQ? You just do like the interval where it would change, or
Which problem?
page 4, part C, on the
Oh.
for these ones, are we, so we don't have to like find the like exact moment when it changes time? Like just the interval?
Let's see. Yeah, because we don't know. We don't know the exact time when it changes direction. We know that at some point it's going to have to shift from a positive to a negative value. But I mean, it could be at 10 seconds, could be at 12 seconds, could be at 14 seconds. All we know is that if it's a continuous function and there's a change in sign, all we can say is the interval where that sign change is going to, or where that direction change is going to occur. That's all we can say. So positive, negative, there's a change from 8 to, there's a change from change of sign between 8 and 20. So we know there's a direction change at least once in that time interval. And then another one between 32 to 40. Now there could be multiple ones. There could be a lot of things happening that we don't see, but we got to have at least one because of the sign change. Okay, any other questions?
I've had an NHS meeting, but could you explain E and G on the second FRQ for our quiz review?
This one here, E and G.
Yes.
Okay, so we know we have to go through extreme value theorem because we're asking for absolute max, absolute min. And we know that we got to test endpoints and critical points. So 0 and 5 are endpoints. 2 is kind of like an endpoint as well because there's a change in terms of what's happening at 2. All of a sudden, coal is being added, so we also need to test 2 as well. And then next is looking for critical points. So critical points is saying A prime equals 0. So A prime is just going to be S of T minus B of T because that's going to strip away the interval. And then I'm just basically going to graph S of t minus R of t, sorry, S of t minus B of t, and looking for the x-intercept. So I graph them into the calculator, and I entered y1 as my S of t, I enter y2 as my B of t, and then under y3, I did y1 minus y2, and I unhighlighted the equal sign for 1 and 2. And I graphed it, I looked for the x-intercept, and I got 4.3. So I need to consider 4.3 hours, 2 hours, 0, and 5, and I inserted them all into the AFT equation to see the amount of coal at those amounts of time, at those points in time. And then I found all those amount of coal and then compared them. Highest is the absolute max, lowest the absolute min.
Okay, so what is A of T? Like where did we,
AFT is the amount of coal at any moment in time.
and then what does A prime of T represent?
A prime represents the rate at which the amount of coal is changing. But the big picture is that whenever we want to find a critical point, we always set the derivative equal to 0,
Okay,
right?
so you're setting the total amount equal to 0.
We're setting A prime equal to 0. The
Okay.
rate at which, because S of t and R of t are kind of doing this, and then we want to figure out, where the max and min are. And A prime is basically, where's A of t going to experience either this or this, because that's going to be where my max and min so could be.
Okay, so usually if we're given a question that's asking for absolute max and absolute min, the question before will have solved A of T.
Yeah.
Like we're kind of building upon that.
Building that, yeah.
Okay,
So it's kind of like extreme value theorem, right? Extreme value theorem, you're always testing endpoints and critical points.
mhm,
And critical points is always just the derivative equal to 0.
mhm.
And this is basically our version of derivative equal to 0. We're creating A prime instead of A prime equal to 0.
Okay.
But because A prime is hard to solve, this is hard to solve, we're relying on the calculator to just graph A prime and looking for that x-intercept.
Okay.
Yeah.
Mhm.
And then part G. Part G is saying at 5 hours, there's no more coal being added to the furnace. So at A of 5, this is the amount of coal that needs to be burned off.
Mhm.
And but B of T keeps working. So we have to figure out how long, we just create an equation. How long will it take between 5 hours and K hours so that this process will exhaust all the coal that's in the first vehicle?
So,
So we
okay,
just set up an equation and that's all it is.
so what is A of 5 and B of T? I think I'm still confused on what A of 5 means in this.
So A of 5 is 512.88.
Mhm.
That's the amount of coal in the furnace
Okay, at 5.
at 5 hours.
Oh, 5 hours.
And then B of T is the rate at which coal is being burned.
Okay,
So however long it takes from 5 hours until it could be 20 hours or 15 hours, however long it takes for this to burn out all of the 512. That's when it's going to be complete.
okay, so it'll always start at when the, when it's that X over A T. Okay, okay, thank you.
Bye, have a nice day.
No.